Hey everyone, welcome to this afternoon's webinar in the 2021 webinar series, the Data Science Corps Wrangle, Analyze, Visualize project. Our presenter today is Nicholas Horton. This is co-sponsored by the AMATIC ASA Joint Committee and by the AMATIC Data Science Subcommittee. Any views expressed by the presenter or commercial products mentioned are not necessarily the views of AMATIC or endorsed by AMATIC. McGraw-Hill is our sponsor for the 2021 webinar series. If you are not a member of AMATIC, we would love to have you as a member. Please consider joining to get updates on future events. We do have a main Facebook page plus regional Facebook pages. We do have conferences coming up this fall in Phoenix, next year in Toronto, along with other webinars and traveling workshop opportunities. And the recordings from this and all past webinars can be found on the AMATIC page at the webinar section. And hopefully the materials for this webinar will be shared either later today or tomorrow. So I will stop sharing, and Nick, I will turn it over to you.
Well, thanks, Pat. You can now see my screen and slides. Again, I want to thank you, Beverly, and the AMATIC folks for making this possible. I'm very excited today to talk about both big picture things about data science and also a specific NSF-sponsored project. My motivation for much of the work I do is to help ensure that the mathematical sciences are engaged in some of the exciting developments that are happening in data science and statistics. And then also really trying to figure out ways of fostering connections, making pathways more straightforward for students, particularly between 2- and 4-year institutions. I have slides that I'll be posting, other information available. My contact information is here, and I'll put this up at the end as well. So I need to begin with acknowledgements. As I mentioned, this is an NSF-funded project through IASC. We have fabulous collaborators at Holyoke Community College, Springfield Technical Community College, and Greenfield Community College, as well as my 5 college compatriots in Western Massachusetts. There's a number of other people I've been working with on some of these projects, really thanking those people as well as many others. There's a lot of exciting things happening in the data science and statistics realm, particularly at the undergraduate level, and I'm glad to talk about some of that at this point. So my plan for the webinar is to kind of talk a little bit about what data science is and why we should care. I'd like to kind of highlight some insights from the National Academy's 2018 Data Science for Undergraduates report. Talk briefly, again, we could talk all week about options for data science courses and programs, but to kind of describe some of the options that people have laid out. So a lot of kind of shopping and other references I hope to have here, as well as starting to think about what programs in data science or analytics are being developed. Many of the institutions, participants, today are coming from institutions that have rolled out data science programs and initiatives, but there's many others that are happening at this point. And then talk a little bit about ways that we feel like the DSC-WAV project kind of complements and builds on this and shows us what we need to be doing in the classroom in the future. So that's my overall plan. Love to kind of get your thoughts and feedback. And the way I'd like to start that is by doing a brief Zoom chat. So my idea here is take 30 seconds or so, if you would, give me a quick and dirty definition of data science. And if you could put that in the chat window, set up for everyone, but don't hit return, please, until I ask. So please take a minute now and give me a kind of a quick and dirty definition of data science. Okay, so hopefully you've had a chance to put something together, kind of refine last thoughts. go ahead. I'd love to see what you're thinking. How would you define individually data science? If you go ahead and hit return. So we have this aspects of using programming more intensely to do statistics, making meaning and gleaning insight from data, gathering, analyzing, interpreting data and statistics, obtaining, cleaning, and organizing data, study of data to find patterns, a discipline combining science, math, to computer science, math, and statistics, the art of handling raw data, making the science of data. These are great. These are wonderful definitions that I think kind of capture some of the excitement that many of our students are seeing as we move into this area. And this is what led the National Academies in a study funded by the National Science Foundation to kind of commission a consensus report on what data science for undergraduates should look like. This is a free consensus report. It's downloadable from that website I've given here, freely downloadable. And it really was interesting to kind of be part of the project that did this and to really think about what things might look like for undergraduate data science. So there's some key insights and findings that came out that really there need to be multiple pathways. This is not a one-size-fits-all kind of environment. We need to be thinking about baking diversity and inclusion in early and often. That's both demographic, intellectual. We're thinking here of data science as a very broad, this capturing insights from data is a very broad thing that has all kinds of key components to it. And we want students to develop what was defined in the report as data acumen. It's interesting, this report on undergraduate data science never defined data science, but it did talk about data acumen and talked about that's something that is really important to instill at the undergraduate level. And then also really the importance of ethics. So that's kind of like some of the key insights from there. As I said, one of these central findings involved this definition of data acumen. And I think of data acumen as a kind of a richer, deeper, more sophisticated level of understanding that builds on a basis of data literacy. And so the key concepts in that fall into all kinds of different areas: mathematical, computational, statistical foundations, a number of data-related capacities, data management, description, modeling, workflow and reproducibility, communication and teamwork, domain applications, and also ethics. A lot of these things, particularly those last set, I think we would have called in the past statistical practice aspects. But I think now we can be thinking of it in a broader way that really brings together the computational, the statistical and mathematical side with really doing this in practice and extracting these insights. I'm going to very briefly go through some of these concepts that make up each of these 10 areas, just to kind of give you a quick overview. Obviously, full details are in the report, but again, there is key mathematical concepts that are important for students in these programs. And again, I think it's critical that the mathematics world is part of some of these conversations. Unfortunately, the mapping of courses we have at present may not be the best preparation for undergraduate or associate's degrees in data science. And this is going to be a challenge for us in thinking about what skills, what courses we can be offering in ways that will help prepare students. Because to get this list based on our current curriculum is a lot of courses, kind of more than we would typically even see with an associate's in mathematics. Computation is really critical. People will joke that a data scientist is a statistician who knows how to program, but algorithmic thinking and abstraction, and again, I think we have abstraction on all these foundational areas. What we think of as mathematical foundations or abstraction are similar, not always the same as what our computer colleagues would talk about, as well as our statistics colleagues in thinking about modeling and other abstract reasoning. But thinking about algorithmic thinking, programming, data structures, simulations are really important parts of the foundation and computation, without which you can't make sense of modern data. There's a lot of things that are incorporated as part of statistical foundations. Some of those are incorporated in our introductory statistics courses. A number of them, still we need to be bringing in much more deeply. So concepts of variability and uncertainty, inference, multivariate thinking is a big deal from the GAISE report, the GAISE College report. Talk more about that a little bit. But these aspects of biases, confounding, and causal inference all too often are not part of that introductory statistics course, but students will need that to kind of make sense of the observational data that make up a lot of data science. Topics: exploratory data analysis, statistical modeling, model assessment, simulations are also important as part of the toolbox for a student thinking about data acumen. Data management and curation are really important, but have not historically been stressed as much. These tend to show up more in information science programs, sometimes information technology, kind of data technologies in particular. But we need to be thinking about the entire data life cycle, data provenance, data preparation, that whole data analysis cycle, with really a focus, not just here's a CSV file that comes along with the textbook that you're going to be analyzing, but kind of really understanding the different aspects of data. And also this aspect of modern databases, kind of thinking about larger things that we can be bringing forward, because there's a lot of work that's happened in recent decades in terms of database technologies. So data visualization, data description, really important as well. Kind of thinking about visual and data consistency checking, kind of aspects of grammar of graphics, visualizations. We hear from the workforce, kind of companies are now saying they're really needing dynamic visualization. So the kind of static displays and things that we've been teaching, we need to go much beyond those. Good news is we're seeing a lot more statistics in K-12, and that may open up some ability for us to build upon this in college, in the first 2 years of college. Data modeling and assessment is also a critical part of data acumen. This includes things that we might think of as machine learning. Machine learning sounds a little bit scary, but again, if we think the most common machine learning technique that's being used is logistic regression. So kind of how can we start to be thinking about aspect of kind of both supervised and unsupervised learning, dimension reduction, aspects of deep learning, AI. These are the kind of things that we're starting to see much more important and kind of much more early in the curriculum. There's a whole very active AI for K-12 organization that's really been building learning outcomes starting in first and second grade, in thinking about AI, making sense of machine learning. Again, that's what we need to be building upon at the undergraduate level. Workflow and reproducibility are really important concepts. It doesn't really make sense to be able to kind of go out in the world and do analyses if you can't repeat them yourself, a month later. And so thinking about tools for reproducible analysis, Jupyter Hub provides some of those, RStudio provides some others, version control systems are critical, GitHub and the like. These are things we've typically had students learn on the streets as opposed to learning in our classes, and really kind of fostering collaboration, because if anything, data science is a team sport. Communication and teamwork, again, really critical. These are things we've been teaching in terms of our mathematics, quantitative, statistical literacy courses, but maybe not as much as we need to. Our business colleagues, I think, have been doing a lot of this very effectively, and there may be some really good models they've put together. But really being able to understand client needs, kind of posing a question and bringing it together with the data that can answer it. Figuring out ways of doing clear and comprehensive reporting, obviously addressing conflict skills in these kind of nimble groups that are working on technical writing, again, thinking about that aspect, and effective presentations, all really important to be an effective data analyst, data scientist. Last, but certainly not least, are ethical concepts. There's a whole bunch of things that have typically been part of kind of statistical ethics, kind of conduct of research and kind of, taking care of research subjects, but a lot more there as we start thinking about data ethics and kind of privacy, confidentiality, algorithmic bias. There's lots of questions there that are really needed for everyone, not just data scientists. So my quick question for you, and I'm going to give you a little bit longer, I'd love to hear about one or two, whatever you can kind of write down pretty quickly, data science initiatives are underway at your institution. Same drill, if you can kind of queue things up in the chat window, and then, I'll ask you to kind of submit that. But, if like Montgomery College, you now have a full-blown associate's program, great, let's tell us about it. If you're at a four-year institution, kind of what kind of things are going on? Please tell us you're at a four-year institution if you're coming from one. But, maybe it's that you're developing a new data science course or exploring some faculty development thing with your colleagues. But please take about 45 seconds or so, and I'd love to kind of hear just kind of one or more things that are going on at your institution. So I'll stop talking, let you queue up the chat, and then we'll go back there in about 30 seconds. Great, so if you go ahead and hit return, if you would. We got some independent studies, that are going on. That's a great place to kind of get started. People talking about a new certificate that's been put in place. They're planning kind of across the institution for data science certificates and programs. Got some people from large places that do a lot of machine learning, like CMU, kind of thinking about these connections. And again, to me, the associate's degree programs, the community colleges, you're the only affordable game in town. So we need to make sure that these programs exist at these institutions, which is why we're really here today. So it's great to see how things are coming together. Some people teaching the Berkeley Data 8 course. So this is fabulous. It's great to hear. And what I'm hoping we can be kind of building this community, and I know that's what the AMATIC committees have been doing to try to support each other, so that people don't have to build this all themselves. So there's lots of different ways to start. I'll talk about some of those, introductory courses we need kind of for students who are going to be transferring. Certificate programs may be helpful to spin up. We have both associates to workforce and associates to transfer programs that may have different kind of needs. But again, coming back to the report recommendations, we need to make sure we have flexible pathways for students. And as I said, my goal here is to make sure that mathematics isn't left out of all these exciting things that are happening. So that takes me to the GAISE college report. So the GAISE report, there's both a pre-K-12 one that's now in its second version, and the GAISE college report, also in its second edition, came up with kind of recommendations for how we would think about teaching statistics. But I think a lot of this is quite germane and relevant to the teaching of data science as well. So there are kind of 6 big ideas. We need to be thinking about teaching statistical thinking. And that needs to really kind of involve the entire kind of process of problem solving and decision making. There's lots of different examples that have been put together for this iterative process, but it's not just like a kind of a straightforward thing. It does involve the scientific kind of cycle of understanding. And we also need to be thinking about giving our students experience with multivariable thinking. All too often, I worry that students come out of an introductory statistics course kind of learning that a 2-sample t-test can be used to compare 2 groups. But if they're not randomized to kind of get that group, and they're not fully compliant, and they're not, again, they're in a situation where they can't make conclusions because there could be other factors. And I worry in a course without multivariable thinking at the core that they're going to be saying, so then what's the purpose of statistics? And what we really find in data science is that so much of the data that's out there are found data or observational that were collected for other reasons. And there are insights we can make, but we need to be careful about them. GAISE talked about how important it is to focus on conceptual understanding, to integrate real data with a context and purpose, to foster active learning, to think about using technology to explore concepts and analyze data, and to use assessments to improve and evaluate student learning. So the chair of this committee is on the webinar today. It's great to have her there as well. And this is a report that I think helps to kind of guide us in moving our courses and programs in a good direction. So obviously, there's all kinds of realities that I need to acknowledge here, because I'm talking about a lot of stuff that's different from what we're necessarily teaching or what we have on the ground at the present. And again, I'm coming from a four-year college working on this project. It's been great to have the opportunity to engage with my colleagues from two-year colleges, community colleges, but there's all kinds of challenges there. There's clearly still a pandemic. We live in challenging and interesting times. We know that historically, there's never been sufficient resources allocated to our public two-year colleges that are doing amazing things, but typically without sufficient resources. Last year was particularly disastrous in terms of enrollments, and that made budgets even tighter and more challenging. At present, there's still not much use of what I would call appropriate technology that really is focused on supporting multivariate thinking and helping students to kind of think with data in a more general way. And we need to kind of be thinking about ways of finding paths forward. And my possible answer here, because I don't think I can necessarily come up with a plan that will solve the budget problems or kind of institute these others, but if we can figure out ways to kind of collaborate and combine efforts so that people don't have to kind of reinvent the wheel all the time in their things. So one question I have for you, and we've already gotten some answers to this, so I'll pretty quick. At present, is there an introductory data science or data analytics course planned or offered at your institution? And if so, which department or programs are offering? And again, particularly interested in what's going on at the two-year colleges. But if you know of information where this kind of course that's being offered has an articulation agreement in your state or with other kind of students, so please do the same thing. Just let me know what kind of courses, introductory courses are offered. We've heard as well, there's some modeled on Data 8. I'll talk about that in a minute. But just take 30 seconds to kind of give me a sense of, and to share with everyone what kinds of things are being offered. Great, so go ahead and hit return if you would. Got some that might be in computer science. We got an introductory statistics course that's offered in the math department. There's kind of some things going on in the Montgomery College program, which kind of has a full kind of set of things. And Rebecca notes the importance here is that the 4 years are often behind the 2 years. This is developing so differently in different places that it's making articulation challenging at times. But again, also these introductory statistics are being an option for this, which again, I think provides a really good foundation for some of those statistical foundations. So thank you for chiming in on those. So there's a number of great options. As I said, things are developing pretty quickly. All of the following are open educational resources. The Berkeley's Data 8 course has a very large effort to kind of build out a community to be teaching what is a kind of a technically challenging course, but a really good structure and framework that looks holistically at how things can work in terms of technology as well as the pedagogy. Mina Chetankaya-Rundell and colleagues have put together her Data Science in a Box course, which is available at the link on that second link. That's proven to be really popular with online tutorials that they've created using kind of free environments through our studio. My shameless plug, our second edition of our Modern Data Science with our book is now available in full version on Bookdown. But there's been some really interesting and important conversations about what this course should look like and how it, I think, helps to establish a basic level of data acumen and how we need to be kind of creating opportunities for students to either stumble or be lured into such a course and to kind of help them to develop the other aspects of data acumen in the future. So next steps for programs were really outlined in the two-year college data science summit a couple of years ago. This happened soon after the report from the National Academies came out. The National Academies report did discuss community colleges and the important role they play. There's been some other initiatives with the National Academies, but the Data Science Summit really allowed people to kind of drill down and to kind of focus in more detail about how to develop different kind of approaches that would provide these very flexible pathways for students. So let me just acknowledge here, developing data acumen and the kind of things that are being discussed is really hard. I co-edited a special issue of the Journal of Statistics and Data Science Education that was focused on computation in the statistics and data science curriculum, and really thinking about these creative structures, novel skills and habits, and ways to teach computational thinking that build on our all prior literature. And it's really hard because we need to think creatively about how to give students repeated practice with this cycle, because it's very clear that it's not just kind of like take a single course and suddenly you develop data acumen. So this is going to require new courses. We've seen some of the introductory courses that are now being offered at a number of your institutions. There are equivalent capstone courses being offered in associate degrees program or in bachelor's programs, and other courses like the Data 100 course at Berkeley, as an example, that build on those introductory courses. But it requires that kind of scaffolding and a circular spiral curriculum. And I think that there are some good models, but there's a lot of work to be done because it isn't the case that just a single course or two will do this. So we've really been working to try to figure out how to deepen data acumen for students. And that led to the establishment of, we wrote a grant, NSF funded it from the Harnessing the Data Revolution program, HDR, and it's part of the Data Science Corps initiative. So this is a workforce grant. This is really thinking about how we improve the ability of those entering the workforce to be able to deal with the data that kind of floods their lives. A website for the project is given here for this DSC-WAV, Wrangle, Analyze, and Visualize. And again, it's really to kind of think about a co-curricular experience that can build on top of this that would, I think, it's already had implications for what we need to be teaching our students. And I'm hoping that this project, which has a couple of components, is relevant to kind of furthering some of these discussions. So as I said, this is a collaborative project with the 5 colleges, as well as the 3 community colleges that I mentioned in Western Massachusetts. University of Minnesota has been doing our assessment and has been tied in very directly with the project. So goal 1 is really focused at students at 4-year institutions. And this is creating opportunities mostly for juniors to be able to work on data science for social good projects for community organizations. So in the first couple of years, they worked for a kind of our bike share system that's put together by a number of our communities, or the Western Massachusetts Health Equity Network, and to kind of engage with messy, large data sets in ways that could kind of move forward the mission of these community organizations. That's been hard. We've learned a lot, and I think we're kind of figuring out how to structure and support student involvement in those. The one way we've been doing this is by using technologies for software development, in particular Agile and Scrum. And these are techniques that are typically used by kind of software developers in companies. And a quote from a paper that we published in the Harvard Data Science Review earlier this year is, while many of these courses and programs teach students relevant data science skills, we can expect coursework to develop students' data acumen only so far. It's unclear whether coursework alone is enough to provide students with the experiences of data and computing they need to be successful in tomorrow's workplace. Ask any employer, when you ask them, should students have a capstone experience for their associates or bachelors? They'll say yes, they should have 3 of them. Again, it's a common thing to kind of get that real world practice that complements their coursework. And that's where we've been trying to experiment with approaches to help make that happen. So the idea of Agile and Scrum is to kind of think about a technique that empowers students in teams to be working together. Again, building on those data acumen components. So work is organized into a series of short sprints. So the students are working over a semester. We've just started the teams that I'm working with this semester. We had our first day of classes on Monday, but they have every couple of weeks, they're working on what we call a sprint. This is a way of breaking up these large tasks. We kind of begin with a backlog, a kind of a plan of things that need to be done, and then tasks that can really move that forward that are the highest priority. And so the team, these undergraduate students and the stakeholders, that's me and these community organization folks, meet regularly for them to share results, have demos, and make adjustments to plan for the next sprint. We use technology to make this more straightforward because it's a lot of moving parts. Kanban boards, these are project boards that can be implemented either using Trello or GitHub projects, are used to review the backlog, team progress. We've implemented aspects of code review with the idea that a team of students is much smarter than an individual, and to kind of help, establish this kind of responsibility and kind of accountability for our students, and to kind of have these aspects supported through the technology has helped them to do better data science. So code review, as I said, is pretty critically important. And if you've ever had kind of opportunities to do peer review in your classes, you know how challenging it can be at times to get students to provide useful, helpful, constructive, and also critical feedback of their peers. But again, in starting to think about kind of bringing everyone up, it requires this back and forth, as opposed to the typical approach that I see all too often with group projects, which is a divide and conquer. And it's like, you're responsible for this part and I won't comment on what's going on there, is not going to get us to the best position in terms of kind of the end product. Lots of things we've been finding and kind of supporting this. And again, this has typically not been something we've previously included in our courses, though we're now adapting our introductory data science courses to do more aspects of code review and accountability. Simple Programmer describes this as an evaluation method to identify code errors, though for us, it's really kind of like logical kind of issues with analysis. And the goal of it is to reveal and remove bugs, improve code, documentation quality, just kind of like up the game of what's going on. And in a perfect world, though this takes time and is challenging, build the kind of the skills and self-confidence of this. Again, 2 heads are always better than 1 in this kind of work, but it's really hard for people to do this in the workforce, even harder for undergraduates to do it. So again, we've tried to figure out different ways of structuring things so that people feel less proprietary about their code, that others are kind of getting involved in it. And we've, tried to figure out ways of making these a positive culture through this process, because again, it's, I think, going to provide them really useful and valuable feedback later on. So the code review, there's some other additional resources here. It's been really interesting to move from a kind of everyone having their own private code to being kind of community-based code. And it really has kind of forced our students to kind of out of their comfort zones at times. And again, this is one thing we've really learned, and I think we need to do more of. A second big goal for DSC-WAV, though, is to foster curricular innovations and connections between these 2- and 4-year colleges to teach data science. And so here we're working to develop intro data science courses and programs at the 3 schools we've been working with, as well as more broadly within the 15 public community colleges in the Commonwealth of Massachusetts. We've been providing faculty development opportunities, kind of working on a train the trainers model, looking at opportunities to foster conversations about articulation. We've been working on trying to develop some aspects of team teaching, and then really a junior fellow program where students could come take computer science, statistics, ethics courses, an introductory data science course in their community college, transfer to UMass or Amherst or other place, and jump in as a junior fellow. And so we're working to kind of foster that kind of seamless pathway for students to engage as juniors coming in as transfer students. So what have we learned? Well, it's really hard. There are many, many challenges to helping students develop the ability to think with data. A lot of the things that were successful for them in high school may not work so well when we think about kind of fostering, the kinds of kind of questions and things we're going to be doing. And our courses and programs need to adapt to give them the necessary workforce skills as analysts. That these projects have provided the starting point, but more reinforcement is needed. And there's really lots of work needed to scale out the programs at 2- and 4-year schools. There's a question that's come in about, kind of an example of this, how this is shaping out. I've been working with a team working with data from this bike share system. And one of the questions from that is, where should they be putting future docks for these bikes, bike share systems? They've, explicitly chosen to put some in underserved areas and are wondering what kind of utilization patterns there have been there. This is pretty complex data because there's, about 1,000 bikes in this system. Each one is sending its location when it's being ridden every 10 seconds. And so you have these kind of paths that are being followed, but by working through that and kind of, mapping, developing some algorithms and other approaches, they can start to see what errands people are using with these and how the bikes are being used and reshuffled. And again, it's been, our goal to kind of also give back to those organizations the kind of data infrastructure and technologies they could be using. There was another project that was analyzing data from a wildlife camera to try to figure out what was being seen when it tripped. And so again, this is another place where a lot of data, a lot of complexity, but a need to kind of make some action out of those data. So the big picture, what are we hoping students will learn when we teach them introductory statistics, when we teach them data science? And I think this kind of image of this kind of cycle that's due to Hadley Wickham and Garrick Rollemond is that they can start by posing a question. They can bring some data into whatever environments they're going to be analyzing, doing that tidying, wrangling, whatever you want to call it, process. And then really think about that iteration of visualize, model, and transform, with the end goal being to communicate, be able to make some decisions based on that data. And this looks a lot to me like the Common Core mathematics modeling kind of, same kind of figure, where we want students to be thinking about how they can be using numbers to make sense of the world around them. And I think that's where, again, my goal is that the mathematical sciences will be really engaged in helping to be part of these transformations, to help teach the courses that will both build data literacy and data acumen. And that we can be thinking about, even at the associates level, the kind of opportunities and things that our students are now doing in their junior year in the DSC-WAV program, that they could be doing as part of a class or an experience at their community colleges. So lots of things needed here in terms of next steps. I think it's critical that we really focus on computational thinking early and often. I think computation can help us get students' hands really dirty in terms of multivariate thinking and data acumen in ways that we've not often done. That we can embrace simplified computational interfaces and approaches to help minimize the cognitive load and scaffold reproducibility. Example, the Data 8 environment is set up where students bring a browser and can connect and engage in using Jupyter Hub in various ways just directly on day one. Same kind of thing has been done with our studio and various other cloud-based approaches. That cloud-based computing, I think, can minimize barriers to technology and allow us to kind of start doing more complex things that is impossible with calculators. We need to think about integrating and adopting high-impact practices. If we're gonna get students out of their shells and working in these areas, we need to foster active learning. And so aspects like paired programming, group and project-based learning is going to be really critical. And then obviously the faculty development aspects of this are nightmarish. There's so much need for stuff that really didn't even exist, you know, when many faculty kind of came out of their original programs. The great news is the software and technologies are now free. Nothing's really free, but there's no cost for most of the software that's now out there. The cost is going to be the time, some ability to kind of make this available to our students in a nimble way, but it's really become a very exciting time in terms of data science. So here's my penultimate Zoom poll, as you were. Please, again, if you kind of start queue up, what's the biggest thing, what's the biggest barrier to data science education at this school? And what would help address that barrier? Please take like 30 seconds, if you would, and kind of queue up a response. What's the biggest barrier? What's the thing holding you back? Another 10 seconds. Go ahead. Yes. So we got finding willing and qualified faculty, faculty development, industry partners. Where's the time coming to find those industry partners? Kind of finding demand. We've had some examples where people have not been able to kind of get that resonance with employers. And again, I'm with Rebecca on terms of the kind of mishmash of courses at four-year colleges that will make it so our students might not be able to transfer that course. That's a killer for us. And there's lots of different competing agendas with different departments. It's been interesting through DSC-WAV. One of our three schools is developing things primarily through their IS and IT department, another one through their business program, and the third through their mathematics department. Again, these often don't talk to each other in various ways, but lots of challenges. National Academy's report, you know, talked about how important it was for academic institutions to embrace data science. They described it as a vital new field, which requires specifically tailored instruction that should have majors and minors, as well as this development of a cadre of faculty equipped to teach in the new fields, and that academic institutions should also provide and evolve a range of educational pathways to prepare students for an array of data science roles in the workplace. Again, I think these are really critical to kind of be talking about how this is important for each institution. We've seen a tremendous development of master's programs in data science. I would argue we can't afford to have most people go through a fiendishly expensive four-year system to get their bachelor's and then have to do a 1 or 2 year master's program. So again, thinking about both bachelor's and associate's programs are really, really important. The report also talked about how academic institutions should encourage the development of a basic understanding of data science in all undergraduates. We've heard about the Data 8 course at Berkeley and how that's being looked at in various ways. That has huge numbers of students who are working through it. I could also imagine that a Joy of Data course, a Data Zero course, could be really valuable that might focus primarily more on ethics and kind of case studies. There was also a recommendation that 4-year and 2-year institutions should establish a forum for dialogue across institutions on all aspects of data science education, training, and workforce development. I'm certainly, as someone from a 4-year institution, highly committed to kind of have that dialogue because it's really critical. As I've said earlier today, 2-year institutions are the affordable game in town. How can we really kind of allow them to kind of help develop? When we think of a pyramid of students, PhDs, masters, bachelors, and associates, to kind of be addressing these workforce needs that we have moving forward. I'm going to leave my next steps poll. You can chime in. I'd love to kind of hear next steps if you have any suggestions, but really want to kind of turn it over for other more general questions or discussion as that makes sense. Again, I'm keenly excited about these things, and I'm hoping through my work, I'm the incoming editor of the Journal of Statistics and Data Science Education. We'd love to kind of read your papers or other things about interesting, creative things that other people could be doing, particularly as that involves kind of student-centered, kind of, what their reactions, how things have been going as you've been developing programs. But thank you very much. That's my presentation. But as I said, I'd be glad to answer questions or if there are other ones or other things, but thank you.
Thank you, Nick. Does anyone have any questions that they would like to put in the chat? Now's a good time to ask it. If you don't have any questions, maybe we can show your appreciation for Nick in the chat as well. Okay, Nick, are you seeing these?
I am, yes. So there's a question, are there ways our community colleges who have successful programs could work with newbies to get our programs going? So yes, that's certainly part of what we had even from 3 years ago in the National Academies report from 2018. It highlighted a couple of individual institutions that were doing some pretty exciting things. We want to continue to kind of foster those things in the same way that the Data 8 course has been an example that may not be perfect, it has different kind of pedagogical choices to it, but we want to kind of be able to get that information to people to help our faculty take those courses in a manner that's going to be, allow some of that faculty development to happen, because you can't teach data science unless you have a deeper understanding of data science. So again, I think in this regard, kind of having more examples and hearing more stories from these different schools. There was a National Academies Roundtable meeting in June of 2019 that focused on community colleges. I helped to organize that with Uri Treisman from the Dana Center at the University of Texas. But again, that also brought a lot of speakers, including a number of the folks who are here today. There's a question about the introductory data science course at Amherst. I'd be glad to talk about that briefly. We've been teaching that course as a course that has 2 prerequisites for it. One is some background in statistics. Certainly could be AP statistics would be enough for that, or kind of an introductory statistics course, and then some aspect of computation, some prior familiarity with algorithmic thinking, how to write a function. And so we've organized that course using the Modern Data Science with R book that I mentioned. We've made the full contents of that 2nd edition are available on the web. But we really work through kind of developing aspects of data visualization and data wrangling, key aspects of ethics. And then we start to bring in some other topics. Because of those prerequisites, we can go a little further and faster. So dynamic visualization, some text analytics, will be incorporated as part of that and part of that class, as well as databases. My colleagues at Smith College, Ben Baumer is the co-author of that book, is teaching that course without any prerequisites. It's a very similar kind of pathway. They just don't go as far, partly because they're starting at a more introductory level. And so I think that idea of kind of figuring out how those courses could articulate to kind of give that level of understanding, lots of work there to be done. And I think it's critical to kind of help support those at 2-year institutions to make this happen.
Okay, thanks. Are there any other questions for Nick at this time? He will be providing the PowerPoint, and we'll send that out along with the recording. You've got his contact information. Wait just another moment. Well, Nick, I want to thank you for this information. It was a good webinar, well attended, a lot of good interest there. So thank you for your sharing. And if Julie is still here, Julie, I forgot to make her a panelist today. So Julie, thank you for your work helping us get this scheduled. There are many other webinars coming up in September and October, so be on the lookout for those. If there's no other questions, that's all for today. Thank you for attending.
Thanks.